If I tell you guys secretly, hey man, that row you are searching, right, 101 is actually there in this block. If I tell you that that row is here, now tell me guys, if you are firing the query, submitting the query, do you still want to go through all the blocks, or better you read this only one block? If you know where it is, I prefer to simply go there. Earlier I was not aware, I don't know. That's why I have to scan the whole. Getting my point? So if you are aware, know about it, where it is, then I prefer to go only for this. How that is possible? Now with each row, right, there will be one hidden column. What column? A hidden column, we call it as a pseudo column. Hidden, right? What is that? That column contains are called as row ID. What is that called as? What is row ID? Row ID is some alphanumeric digits, some 12 or 14, I think. So yeah, 14, right? Or 16, I hope. I forgot. Really missed one. Sorry. Right? A row ID is a 16 digit, I hope. Yeah, it's a 16 digit alphanumeric values. 16 digit alphanumeric. So what is this code indicates? Few digits from there, letters actually, yeah. What they will say? They will tell you about the file. That is a file ID or file number. I'm giving hash. File ID. Right. File ID. Because there are in database, there are so many files I have. It is telling that which is that file. Each file is having an ID. It will tell you this is the file ID. It will represent to that file ID. Next, a few letters will represent to the block ID or block number. Block ID. File contains what? Blocks. So which is that block you're talking about? Let's say this is the one, right? Which is that block? That block ID. Now what block contains? Rows. The next few letters will tell you the position of the row. Row position. In this block, where it is exactly located. Something like your address or my address. It is completely unique throughout the world. Start reading from below, bottom to top kind of thing. Start reading from below, right? In India, where it is, in Telangana state, Telangana, where Hyderabad, in Hyderabad, where SR Nagar, in SR Nagar, example, office address, where in SR Nagar, near community hall, okay, near community hall, this is the building, in that building, second floor, in that floor, there are multiple are there, in that floor, door number 202. Unique address are there, is there or not? All our addresses, they are unique. The address, block it will tell you. Geographically, it will tell you the pointer, exact pointer kind of thing. Same way, database is a collection of files. Now, where is this row there? In this particular file, in that file, in this block, in that block, this is the place where your row is there. A 16 digit, yeah, it's a 16 digit alphanumeric. So what I need to do simple, change this one. Instead of saying where that one, I have to write where row ID equal to that 16 digit row ID. If I do this way, select where row ID equal to row ID, you are directly telling which file, block and position. Now it will simply go to this block, performs an IO, brings that block here, correct? And simply go to that particular row, take the value from there and return it back to user. How many IOs I did in this case? Only one. How many scans I did? Only one. Right? This is the fastest way of getting your data. This type of scan or going through the row ID, we call it as row ID scan. What is that? This is called as This is the fastest scan in database, and this is the slowest scan in Oracle database. Keep it in mind. Which one you prefer? Row ID, obviously. But again, just practically think, can you always refer or use row IDs in your queries? Instead of saying where employee name equal to Akal Singh, where row ID equal to, what is the row ID you want to mention? It's not possible, right? I can say your employee ID is what? Normally we refer by name or employed and all, but not with the row ID. 16 digit, who will remember practically? Correct? Not easy. Do you remember your Aadhaar number? How many letters in that? Not 16, man. 12, right?
12.
Yeah.
12, 12, 12.
12, good. But do you remember? No. Because we won't use that in our day-to-day communication or anything. We won't use. That's why not possible. So seems like practically using row IDs in your queries like this directly by the developers or anything is not really possible. But this is the fastest way of scan. Then, so Oracle also understands that, yeah, row IDs can't be used. There is no mean of having this one or using it. So Oracle came with a solution, a better way. Why? If you are not using row ID scan, what is the scan you will end up doing? Correct? You are going to end up
Full table
doing
scan.
the full table
Full table
scan,
scan.
which will take the maximum time. Correct? Because it has to read the entire table, all the 10 blocks, nothing but 10 IOs and 10 scans. So please understand what is related with your IOs. Who will do the IO, guys? Who is doing IO? Which component in your server? Which component in your server? Which component in your server is used to do IO? Which component in your server? Who is that? CPUs are used in doing IO. If you're copying a file from your D drive to E drive or USB hard disk, you can see your CPU is high. Correct? Any activity, every process, they use what? CPU is used in doing what? IOs. The more the IOs, the more you need CPU. Simple logic. Connection, there is a connection. Now CPU is also used for one more purpose, one more reason. What is that? Next one is? Next one is processing. Processing of your data. What do you mean by processing? The scanning you did here, right? Scan each and every block. Now, who is going to scan that? Server process will do scanning the block, but server process needs what? CPU is required. It uses CPU in searching those blocks. For IOs and also for processing, CPU is used. The more the IOs, the more CPU. Less the IOs, less CPU usage. Simple. Yeah. Processing and computation means what? They all fall into this one. It's processing. Processing means what? Preparing. Example, this is the query. Let me say another query. Select all the columns from EMP, order by salary. Now, the data what you got here, is it in order format? No. It has to take the rows, arrange them in order and give it to you. Right? Processing means as per your query request, I am processing the data and giving you. Raw food processed and given as you need. So if your query says order by, let me arrange in order and give it to you. Correct? Group by, sum of, calculation, arithmetic expression, whatever it may be expressions. The data is not as it is, what you are expecting. So I have to take the data, arrange it as per your query, process it and give it to you. Your computation, everything is nothing but your processing of that. Got it? Mainly two categories. One is the IO, CPUs in IOs, another also. Now, What I was talking here now, full table scan, where it will do the scan on the entire table. The bigger, the huge the table, it will do more and more IOs. It also requires more CPU. Keep it in mind. Done. Row ID scan is the fastest one, correct? But we can't use it directly in the queries like this, right? Okay, Oracle came with a solution on this one. What is that? Oracle says, let's do one thing, right? Let me come up with another object, a object. Same, what is the size of the block? What is the size of a block, please? 8 KB. I'm just going to keep little bigger this one, 8 KB. And here you got the main column which we use in the where condition. Now, in this query, as per the example, where, what is the column I'm using mainly? Employee number. I'm going to use the first column is employee number. So I got all employee numbers here. First column in that. And the second column is the row ID. The row ID of that employee column. Employee ID 100. What is the row ID? 101 row ID. 102 row ID. 107 row ID. 125 row ID. Got my point? Like this, the second column is what? Row ID. The first column is called as a key column, is also called as what? Key column. This is the main column on which you are creating this object. Correct? You have a key column and the next one is what? Row ID. Now, how many columns I got in this? How many columns I got? Columns. 2 columns. So, in a table, how many columns you have? There might be many, right? Might be 20, 40, 50, 80, 100, 150, 200, up to 250, 255 you can create easily. Huge. Generally, you see 40, 60, 80 columns common, right? But here, how many columns are there? Only 2. As per the example, previous example, here it was there. The block size I told, right? Yes or no? You remember? The block based on the row size, how many columns? Example, 10 columns are there. The size is of how much? 1 KB. Now, how many columns are there? Only 2 columns. So, obviously, the row size of this is very much smaller than the row size of your table. Agree? Correct? Because tables are having 20, 40, 80 columns and here there are only 2 columns. The size is very small compared to this. Agree na? Done. Okay, what is the size of this block even? Now, here with the 8 KB, you are able to fit how many rows? 10. I can say now, because of only 2 columns, I can fit more number of rows. In the same 8 KB, I am saying how many rows I can fit now easily? 50 rows. Obviously possible. Correct? One block, 10 rows here. In one block, 50 rows. So table contains totally how many rows? 100 rows. So how many blocks I need in that case? Only 2 blocks. Agree, please? Right? Total 100 rows. We require only 2 blocks. These objects are called as indexes. Object, I'm telling. Object. Table, your table you create is also a object. Table is also an object. Index is also a type of object. Type of object. Got it? Normally books in schooling, we see books. But again, in that we have different books. We will have a single rule book, right? Double rule book, some square books, plain book. Different type of information, different type of books are used. Correct? For drawings might be we use the plain. Correct? Yes or no, please? Getting my point? For mathematical kind of thing, we'll have a square one. Schooling kids and all, generally they do, right? Different type of information are to use. We have different types of book. Same with objects. These are all objects. Different type of requirement. We have different types of objects. So one actual main object is where we keep all our data is our table. Right? This is the one, your table blocks. But we got one more type of object. What is this? Index is another type of block object which contains only what? A key column and a row ID mainly. Okay. Now what is this key column? Nothing but the column which is basically used in what condition? Please keep it in mind. Where condition. Very important. Where employee number 101. So what I'm saying now, I got index with how many blocks here? 2 blocks. So let me keep that index also here. We got index with 2 blocks. Index with index with 2 blocks. Now, when I fire this query, where same query employee number 101, my server process will check or go to what? Do you have index? Yeah. So it is going to do an IO on the index and load these blocks or bring these blocks into memory. Let me keep it from this side. How many blocks? 2 blocks. It's a single block with a row. Okay. So we got 2 blocks. Let me keep this way the blocks. 2 blocks. By scanning these 2 blocks, I will find that 101. Yes or no? Okay, where it is example, this is 101. And what you found with this? The row ID. I got the row ID from here. My query remains the same. Same query where employee number 101. I'm not using this anymore. Where employee number equal to 101. 101. So I think I can remove this row ID below. Okay. Shall I remove this? Any of it is there in the recording, guys? Right? Not to worry. Now, where employee number equal to 101, these 2 blocks are loaded. After scanning these 2 blocks, I found that employee number here in one of the block, and I found the row ID for it. So what that row ID? Which file? Which block? So it is going to load this block now. Agree? And get that row. Now you got that row and given back to the user. Now in this case, how many IOs I did? Two on what? 2 on index block. By scanning those 2 blocks, I got the row ID. Next, how many IOs again? 1 on table block. Then I got this table block loaded and scanned that 1 block and I got the row. To get the row, total how many IOs I did? 3. 2 on index and 1 on table. 3 IOs, 3 scans, and I got my data. Make sense? Please tell me fast. Yes or no? If I don't have this index and if I fire this query, there is no row ID in this. When I fire this query, what it will do? Tell me please. How many IOs and how many scans? 10 IOs or 10 scans. Correct? By just having this one object created called as an index on my table with the key column called whichever is used in the where condition, same whichever used in the where condition on the same column you are creating this index which will contain the row ID. Next time when I submit the same statement where employee number equal to 101, it is going to load these index blocks first to scan that and I got the row ID from there and then I will go to my table block and bring that one single table and get the value. So 2 IOs on index and 1 IO on my table, total 3 IOs. Full table scan, totally 10 IOs, 10 scans. Full table scan, 10 IOs, 10 scans. Going through index, 3 IOs, 3 scans. Which one is better, faster? Index scan. Tell me please. Less IOs, less CPU, faster. Index scan is good or not? Indexes are really good or not? Tell me please. Yes. What is the benefit of having an index? It will speed up your queries, retrieving your data faster, getting your data faster. Please understand. That's what here you see. Clear? Understood? Right. Indexes. Understood, please, everyone? Sure? Be with me. There's a lot more content. So all related here. That's why if you miss a bit in between, then gone. Will slip the chain. Right. Indexes, table scan, going through index, using an index and going through index, right, is called as index scan. What is this scan called as? If it is using an index and doing index scan, which one you prefer better now? Full table scan or index scan? Obviously, index scan is good. Done? Understood? Okay. Okay. Now let me add few more things in this now. Let me add few more things. What is that? Let me change the query here, man. Another example, say where department number equal to 10. I'm coming with another example where what is that? Department number equal to 10. If this is the query, fine. So select all the columns from EMP where department 10. And I'm saying you guys, we have an index event. We have an index, right? With a key column of what is that key column should be? Tell me please. Department number, and the next column is going to be what? Row ID, row ID. Department row ID. Perfect. So there should be an index with that column. Right? Okay. Simple, man. Uh, in books, we have indexes. It's not new here. Already we have. From our schooling time, we have. Right? But we never looked onto that. We have index in our book. Right? A big book, a DBA book with an index. If I say you, please, can you open the undo management? Not in this, study books, not the notebooks, study books, right? So you'll have an index. If I say, please open chapter undo management today. So, okay, what you will do? Go to that one. Undo management. Where is the chapter? Okay, chapter 12, undo management. What is the page number? 250. Let me go to 250. Helping you to immediately jump to the chapter. How much time it will take? Hardly 5 seconds, 7 seconds. You are on the page or not? Correct? If I tear out those pages, initial pages, index, and I'll give you, if I give you that 500 pages of book, go to undo management chapter. From the first page, you will start searching. Where is undo, sir? How much time? 10, 15 minutes? Someone has to search fast. He'll tell, hey, page number 58. Okay, let me go. Everyone will go to 58. Right? Index is helping you there. If you don't have index, you have to search page by page. Indexes are really important, helping you to speed up. Then index must be created on what? Chapter names, because I told you chapter name. I told you chapter name. The index should be there with the chapter name and the page numbers. Only two things, chapter name and page numbers. Correct? Same thing here. Index should be on the column where employee number, then there should be an index with employee number. If I say where department number, there should be an index with a department number. Keep it in mind. Required. Correct? Because sometimes if I ask you, hey, can you please tell me about shared pool? Read the para about shared pool. Where you will find now? I'm not talking about chapter. I gave you have the book. Please read it, the paragraph definition about shared pool. You have book, read. Where you will search? Difficult, right? On the chapter pages, I don't have. Nowadays, many books we have at the end. What is that? Appendix. Letter based. I can go there. I can search for SSS. Yeah, I found yes. Then shade pool. Right? N number of pages. It is referred, mentioned there. So, using that, I can go to that. That is another type of index. Another type of index only, appendix index. Helping you to immediately jump. If I tear out those papers also, can you find? No way. Getting my point? They are helping you to avoid the book scan. If you don't have this index in your book, then you have to scan page by page to find the things. Very difficult. So scanning the book is nothing but here what? A full table scan to find out where it is. I can avoid that by having what? Indexes. And using an indexes, getting your data from table is called as index scan. Correct? An index must be created with the column which is used in the where conditions. Done? Now, for you guys, a small question. Where department number 10, this is the query I'm submitting, and I have an index on department number. Now tell me, if I submit this query, what you want to do? You want to go through index scan, or you still prefer to go with a full table scan? Which scan you prefer? Correct? Yes or no? Index scan. Faster. Right. I'll give you some more information here. Let me add into the same query. Let's say these are the department numbers. We got department 10. Sorry, let me write here. We got department 10, department 20, department 30. Right? And department 10, we have 90 rows or 90 employees belongs to department 10. Department 20, we have only 4 employees. Department 30, there are, so total how many employees? So how many rows you have? 100. So department 10, how many rows are there? 90 rows. Now if I submit the query and as you said index scan, right? Okay. How many rows it has to return you? 90 rows it has to return. Correct? So if I go through index scan, 2 IOs on the index, 2 IOs on the index, 2 blocks I got, then how many row IDs it will give me? 90 row IDs, because 90 rows are there, department 10, how many row IDs will return from index scan? How many row IDs? 90. Each row a row ID. 90 rows, 90 row IDs. 90 rows means how many blocks? Nearly 9 blocks. So nearly 9 blocks, from your table. Got it? Nearly 9 blocks. Total how many it became? 9 plus. Tell me now. How many IOs totally you did here? 11 IOs, 2 on index and 9 on table. It became totally 11 IOs. Now tell me which one you prefer better now? Index scan or better go with? If I go with a full table scan, how many IOs and scans? If I go with a full table scan, how many IOs? What happened, guys? Please. 10 IOs. Full table
10
scan.
IOs and
How
10,
many?
10
Full
tools.
table scan. All 10 IOs and 10 scans.
20.
If I go through a full table scan, 10 IOs, 10 scans, keep it in mind, there is no change in that one, right? Full table scan, 10 IOs and 10 scans. But if I go through this one index, we got 2 on index, and on table as 90 rows are there, 9 blocks. So 9 plus 2, how much it became? 11.
11.
Another biggest problem there. Every time it will go to index scan, found the row ID, it will go to table, bring that block, take that row. Again go to index, go for the next value, take the row ID. Again based on the row, go to table. That means 90 times it is switching between index and table, That is extra load on the system. Correct? So which one you prefer now? Do you want to go with a index scan or do you prefer to go with a full table scan? Full
Full.
table scan? Yes or no? Please tell me fast. Fast, fast. We
Yes.
have lot more to go today. Full table scan? Yeah. So it means that what I'm understanding, having an index, doesn't mean that you should always use index, right? Having index doesn't mean you should always use index. No, we need to calculate, put our brain, calculate, understand which one is good and better and use that method. That's what, right? So as I told you guys, we have an index. If I say where employee number 10 or let's say where department number 10, what you prefer now? Tell me guys. Index scan or full table scan? Where department 10, index scan or full table scan? Which one? Full
Index
table
scan.
scan?
Full.
Correct. If I say where department number equal to 20, tell me what you say. Department 20 or department 30, which scan you wanted?
Index scan.
Index scan. Department 10, so you're changing your
Full table
decision.
scan.
Correct?
Full table scan.
Right. Full table scan. Getting my point? Now, we need to decide. Yes. But server process is a brainless guy. He's not like us. He can't make all these decisions. He don't know all this part. Right? So what happens here now? After parsing, right? After parsing, once statement is validated, the server process job is to bring the data from the hard disk from your file. How it has to bring the data? That is called as explanation execution plan. Okay, so in database, we have one brain or a engine called as optimizer. Optimizer. It is actually Oracle brain, we say. Optimizer is the Oracle brain or a engine. Very important. Right? Now, once the parsing is done here, once the parsing is done, server process will give that query to what? Optimizer, the engine, right? Using optimizer, what optimizer will do? It will take two inputs. Basically, there are many more, but normally it will use these two inputs. One is called as object statistics and another is called as system statistics. I'm writing it shortly, stats. See here, my table contains how many rows? How many blocks? My index contains how many rows and how many blocks? Right? If you are giving like this, where department number equal to department numbers, what are the different department numbers and how many rows are there given? Getting my point? Table, index information, this information helped you to decide, no, I don't want to go with index, I want to go with a full table scan. Without this, what you said? Index scan only. When I said, okay, department 10 or 90, then what you did? You shifted your plan to this one. This information helping you or not? Without this, can you make a decision? To make decisions, you need the information, right? All this information, whatever is here, table level information, index level information, column level information, on that particular column values information, we call these, all these are statistics. What are these? Statistics. These are the statistics. So it needs that object level statistics and another is what? System level statistics. Two levels of statistics are required, and using the statistical information, it will come up with multiple multiple access path. Multiple access path. Example, guys. If I am new to Hyderabad, I have some meeting in high-tech city. So I'm asking you guys, hey guys, I just help me. I want to go to high-tech city. So what is the mode I transport I can choose here to go? You're saying, sir, better you take an auto, right? So you can go by auto. You're saying, okay, no, sir, you can just behind our office, there is a bus stop is there. These number of buses are very frequent. You can take even a bus. Oh, another option. You said, sir, why can't you take a metro? It's nearby and there is also a metro station near high-tech city. Easily you can go in that. Correct? The other guy said, sir, better book a cab. Book a cab and you can take it. No need to walk even anywhere. The cab will come door to door service kind of thing you can take. Now one more guy says, sir, book Rapido. Nowadays we have one more Rapido booking. Take a bike. If you are alone, take a bike and you can go. So many options. It becomes difficult to make a decision. Right? Yes, when you have multiple options, we start looking at them. Hey, I need to again do the same. Hey, if I take the auto, how much it will cost? And if I take a metro, how much it will cost? Or if I go by bus, or if I take a cab is very expensive. I don't want to go. It's like a 300 bucks or 500. Auto might be 150. Bus might be 50 bucks. Metro might be 30, 35. Fine, good. So based on that, I will decide. I decided I want to go by metro. Correct? Now, when I want to go on Monday morning or next day morning, 9:30, I want to go to high-tech city. Important, immediate interview call I have to attend. Do you suggest me to go by metro by morning 9:30? Oh, 9:30, don't go, sir. It will be very crowded. Correct? What we do? We change our plan. No, better let me book a cab or auto. Let me pay extra. I want to reach faster. My target, I want to reach faster. Example, I booked a movie ticket and the time is very close nearby and I have to rush. I can't take an auto or I can't go by bus. Not auto by, I can't go by bus or a metro. I can't wait for a metro or a bus. Immediately we book a Rapido or bike or something cab and we go immediately rush. Yes or no? Plan gets changed time to time. Change the plan. Same thing here, right? Your system statistics, what is that? How your system is nothing but your server. Database is running inside a server, right? And database uses what? And what is this? Memory area, CPU, memory, the number of IOs are happening. All these calculations are really important to make a decision by whom? If it finds there is a lot of CPU free idle, if the CPU is idle, much of your CPU is idle, I'll come up with a plan to use maximum CPU and get your data. No, if the CPU is very busy, I need to look at for a plan where minimum to minimum CPU I have to take and come out with your data. Yes or no? Right? So that's what. So multiple access path, nothing but if I give you these values, you would have decided department 10, 90 rows. What we did, if I go through index scan, first we calculated index scan 2 plus 9, 11. Let me try with table, direct table, only 10. Then I decided, okay, I want to go with a full table scan. So, but I calculated both. If I go through index, what will be the number of IOs? If I go through full table scan, how many IOs? Correct? Right? So like that, please. Indexes are used for what? Index is an object used to avoid a full table scan. Now, it's not only index. It's not only index. Let me write it here. There are many more objects are there used to avoid full table scan. What are those? One we seen here. What is the type of, what is that object called as? Index. Apart from that, we have other objects called as partition tables. They also used to avoid. Okay, there is one more thing called as materialized views. They also used to avoid full table scan. These are all used to avoid full table scan. There's one more thing called as the materialized view logs. Few more, but most commonly, mostly used are these. So these are the different types of objects used to avoid different purpose, different requirement, as I told you, right? For mathematics, I will use a square book, correct? For drawings, I will use a plain book. Getting my point? Yeah. So like this same way, different purposes, queries, objects, everything. We have different objects here. All of these objects intention is only one to avoid what? Full table scan. Avoiding full table scan. Now, if you have so many of things on your table, then it has to check. Hey, if I go through index scan, if I go through full table scan, if I go through partition scan, if I go through materialized view, right? How many IOs, how many IOs, how many IOs in each one? And out of these, I'm going to select the one plan path as execution plan. So I was talking about the multiple objects, right? Different types of objects used in avoiding full table scan, right? So optimizer will check out if you have any dependent objects on your table like that, it will check for each one. If I go through index, if I go through table, if I go through partition and all like this, it will calculate. Not only that, might be you're doing a joining. Joining means what? 1, 2, 3 columns from table A, 4, 5, 6 columns from table B. So the two tables data to be joined and a report should be given. So when you are joining like this, there might be A, B, C table you are joining, selecting few columns from here, few from here, few from here, and you are getting a report. Right? Joining multiple tables, retrieving the data. So in that case, optimizer need to decide which table should I join first. Should I join first A with B and output with C, or should I join B and C first and then output with A, or first A and C then join with B? Which joining method should use? Different methods are there. Which joining order should I use? Different orders are there. All this is getting my point. So it will come up like this: table A, B, then C, joining method, joining order. Then tables B and C with A, joining method, joining. So many multiple access paths it will internally design. And out of all those, one is selected and given to you, called as what? Execution plan. One is given as execution plan. So when you submitted the query, after parsing, the optimizer comes in picture using your object level statistics, your tables, columns, indexes, information, and also system statistics also used. And using these information, how much CPU, memory used, free and all, based on that it will come up with multiple paths. Out of those multiple, it is going to select the one as a execution plan, right? On what basis it is selected? The one is selected based on cost. You've seen the Maruti ad, right? That guy tells so many features about it. At the end, the other guy asks, "How mileage kitna hai?" Right? Kitna deti hai mileage, right? I'm not worried about all the features. Just tell me mileage. Same way, like we see so many products, and at the end, when we rotate the tag, oh, expensive, keep it aside. Cost is another factor to make a decision. Correct? When you go for any shopping and all, even generally, yes. Cost, yes, most of us cost. Same thing here, cost. But this is not the cost here. What do you mean by cost here? Cost is nothing but usage of resources. Usage of, what do you mean by resources? Resources means we got, yeah, what is that? CPU, memory, and IO. The amount of CPU, amount of memory, and the number of IOs I need to do, all these are calculated and considered as a cost. The lower the cost, nothing but the less CPU and less memory usage. So whichever the plan comes up with a lower cost, that is selected, considered as what? An execution plan. Done. So optimizer is the one who is generating an execution plan for you. And once the plan was generated, given to my what? Server process. Server process job is to simply follow the plan. Now what the plan given by optimizer to me? I'm not generating the plan. I'm just, with the help of optimizer, I'm getting the plan. So once I got the plan says index scan. I'll simply go to index and bring the table block, right? And then take the value and return it to the user. The third step is what? Fetch. Hope you guys understood, right? Lot of things are there. I'm going with a slow pace. I hope you guys are understanding, right? I'm sure Novel will give you this kind of detailed explanation, guys. And nowhere you will find even that, right? Even the books, they won't be. But now you got this part right. After understanding this one, I'm sure if you read any architecture book, easily you can understand what they are saying, where they are related, because a lot of things are correlated. Correct? So here today we talked about many things. The query, right? A full table scan, row ID scan, index scan, different types of objects, the sector size, block sizes, CPU usage, correct? IO part, and also the optimizer execution plan based on the cost nothing but the amount of CPU usage, memory, and IO, and based on those things calculations, optimizer will choose the one, and that plan is given to the server process. Server process job is to simply follow the plan and get the data. So now who is bringing these blocks? Index blocks, table blocks, who is going to bring this? Tell me guys fast. Huh? Server process only. Server process responsible to bring these blocks, right? And then take the values from the block and return it. Fetch operation is also done by the. Understood? Understood? There's something more left here. Let me cover. What is missing here? One. Optimizer uses what? With these statistics only it can come up with a plan, correct? Better plan. Now where those statistics are there? Not on the board. Where it is in my database? We have on the board, right? Where it is? All that information is also stored. Sorry?
In dictionary data tables.
Yeah, correct. So in data dictionary tables only, there are set of tables, right? Where we have our statistics. So same, these are the same set of tables. What we already discussed here, metadata, right? Metadata. Now we also got here, what is that? Statistics. So your statistics also stored in the same data dictionary tables or base tables. That means for my optimizer, it needs, right? My server process is going to do again an IO on the statistics and bring this data here. So we got statistics here. We got the statistics. Now using the statistics, it is going to come up with an. Now, if I look at my whole entire query, please just look at, follow the query. When I submitted the query like this, the user process given the query to server process will do first what? Parsing, to do parsing, what is required? Metadata. That means it is going to do an IO and bring your metadata here. Is that correct? Now using this metadata, it will complete the syntactical semantic checks. Once that is done, then with the help of optimizer. So optimizer needs statistics. Again, it is going to do an IO and load the statistics into this memory area. What is this area actually called as? Shared pool. Which area? Data dictionary cache. Right? So you got your metadata here, and here you got your statistics. Using the statistics from memory, then optimizer comes up with a plan. Comes up with a plan. Now server process will follow that plan. Before following, there's one more thing let me add. Right? You got the plan. Once I get the plan here, server process, what it will do? It will take some memory area from this cache. What is this area actually? Library
Library.
cache or cache.
Library
Memory
cache.
area. Yeah. In this, your statement, your parse code, your execution plan. Statement, parse code, execution plan is stored. Right? And then it will go for what stage? Fetch, nothing but bringing the blocks from the disk, scanning them, taking the values required, rows, and returning it back to the user. Fetch operation. So we'll stop it here today, guys. So next session, we'll continue further with the other components. Done?